Okay, I'm going to work, we have this problem worked online using OpenCPN, where I did it all digitally using range and bearing lines and things like that. Now I want to work the exact problem, IN05, quiz 5, number 7, but we're going to do it with a traditional method, parallel rulers and dividers, or one of these roller plotters. So here's what the problem is. It's simply a transcript, well, simply, I don't know if it's simple or not, but it's the process. It's a daily process you do when you're doing real navigation. That means beyond just GPS, you're doing real navigation. Then you have a logbook that says, it records all your course activity. So, and then, so we have a logbook at time 0. We had a log, and that log is just the odometer, how many miles through the water has traveled since it was set to 0. Course 305M. And then here's a GPS fix like that. And then there's on the wind here. Now what? Okay, so why do they tell us a wind? Wind is 15 knots at 280 true. The variation on this chart, we always use 20 degrees east. It varies like a half a degree throughout the chart. We always use 20. And that's back in, again, what is this chart? 1998. So this is a chart, training chart, frozen in time, 1998. So find the best estimate, apply 7 degrees leeway. So we're assuming that this person who made the logbook knows that their boat and this wind speed going to weather has a 7-degree leeway. And this must be a route to a close hauled on port tack. So we'll see that tacking. And then we have to correct for leeway. And what we generally recommend if you're trying to correct for leeway is probably first lay the course out without leeway and then just correct it from that. That's maybe the easiest way. Or you could do it, you could correct every single track that way with leeway. But it's a little bit easier to keep in track. Once you got the route laid out without leeway, then you draw in the wind, draw in some wind arrows, and then you'll know that the downwind legs are when you're tacking to weather, it's going to be pushed downwind, and you know which way to go, because on one tack it'll be plus, the other tack it'll be minus. Okay, and so here is this, and this is magnetic. Okay, so let's start out, and then they went on from 1 o'clock till 2 o'clock. At 2 o'clock they have traveled this many miles, according to the log, the odometer, this many miles from here to here, and then they tacked, or changed course to this one. And then on to 312, and the log read this, and they did this. We don't have to have speed here for doing this, but in fact, we don't even really need to know the time because we're not dealing with currents. We could do everything just with this, just with the log and the course. But if we're going to correct for current, if we want to go back and even retroactively sometime correct for current or discover there was current, then you need to know how long you're in the current at each step. So we'll label these points with the time. All right, so we start out, and let me just do a little preliminary work here. How long were we on course 305M? From 21, okay, so I can do that in my head. That's 3 from 8 is 5. 1 from 6 is 5. So this leg was 5.5 miles. Then this leg is 8 from 14 is 6. And 6 from 12 is 6. Oh, 6.6. Now this one is 3. 4 is 0.3. And then 2.3. So these are the distances we were on each leg. That'll come. You'll see that as we plot this. And then this is, of course, 305M. Now, if I use this tool here, the Weems parallel plotter, this one does not do magnetic. Everything is true. And so we would, if we're going to plot these in true, we would use true here. But look at here. Remember the correcting, add east. And correcting means go from magnetic to true. So true equals magnetic plus variation east. The variation for the whole chart is 20 degrees east. So there's the formula. True equals magnetic plus 20 east. So if we want to use true, we would plot this at 325. We would plot this at 235, 320, 320. And that's what I'll do with this. But you can use parallel rulers and take that bearing off of here. I'll illustrate the first one that way, and then let's see how we're going to do this here. Okay, so let's start. And we got to, first of all, so this is a good exercise. We got to, first of all, plot a position where we're starting. And it's a 48 degrees, 18.8. So let's mark the longitude, the latitude first. And we go over here to the scale. This is 48 degrees. 48 degrees, 10, 20, 18 point, and can that be seen? And you zoom in, there's these tick marks, count them, 1, 2, 3, 4, 5. Yeah, so that's 18.5, 6, 7, okay, 5, 6, 7, 8. 8 right there. So then I come over here and I roll this down to here. So I am that far below this parallel here, okay? I'm that far below that parallel. Now I'm going to come over here. What's our longitude on the first one? 123. 6.5, so it's about here. 6.5 is about here. So I'll just come in here. I can just go in like this, and now I've got the right latitude marked here. Then I can come up with a tool like this, and you see what I'm doing here is making this line up with this. So that that's my distance. Okay, so I know my starting latitude is somewhere on this line right there that I just drew. Which is that is there. Then I come over here, you see that's 18.8. All right, that's that. Now the longitude is 123, 6.5, and down here at the bottom, 123, 5, 6, 6.5. And you see, I've written these in, both of them. I went ahead of time and wrote these in with pencil. That's always a good idea. That makes you can stop and do it when you're clear thinking and not underway. And then I don't have to recount every time, and I know it's right. So I got it marked ahead of time. I want 6.5, it's here. My closest meridian then is over here. So I'll just bring that over to there, and there's now 123, 6.5 is right here, but it's this far to the right of this one. So I can come up here now to here, and put that on there. Now I can go up again and do the same thing, or I can, make it parallel here. Put that on there. Let's see as carefully as I can, and then just roll it over here. And here's that. So here's my starting point. Now I'll put a circle. That's a GPS. So that's all. We haven't even started the problem yet, but we have our position plotted on the chart. That's that one. Now, we want to head off in course 305M. Now, I want to do this once with parallel rulers and then switch. I'm going to slide this down because we don't need the scales there on the bottom anymore. Okay. Let's see, here's our point. And we want 305M. Let's say we're dealing with M's. So here's magnetic, and you just have to focus in here. Hang on just a second. The word focus meant get the right glasses on. Okay, now that's better. So we want, if it's 305M, so I come here 300, and I have to count them out. 300, this labeled 300, then it's labeled 330. So this means this is 310, 320. So these things are every 2. 302, 4, 6, 8, 10. So we want 305, so that would be 2, 4, 5, right in the middle. Now, that's why it's a little bit, these things here, these plotters are a little bit easier in some cases. But if I wanted to do that, then I have this thing planted. Then what I do is I plant that one, then I roll this up till this one just touches that line. Then I know I'm on the right place. Then I can move this one. I hold this one down tight. Then I move this one. Then I move this one over to here. And there I'm on there. And so there's my course I'm starting out with, like that, 305. Now you could, if you want to be double safe, you would go back here, move this back and check that it's still at 305 here. Okay, but we're going to check it a different way because we're going to do it different method. Okay, so we're going to use instead from now on. Okay, that's how you use these, and they're check that these don't get loose. Okay, now that's how you use those. But oftentimes these things are a little more convenient. If you have a big chart table, you know, plenty of chart table, these are, or kitchen table, whatever, these are usually easier. But as soon as they don't work, like you're getting over here somewhere, it's getting over on the edge and it doesn't work, then don't even think twice or fake it or try to push it. Just throw them aside, grab the parallel rulers, which will work, you know, and then switch to them. So generally on the boat, you'd want to have both of these. Okay, now where are we? We want course 305. No, okay, now I'm dealing with true, correcting at east 20. 325. 325. So now what I do is I just set this on here. Set this line center. This is going to be centered down here on this parallel meridian. And then I want 325. So I'm lining up 325. You see, that's here lined up, and here's 325 lined up. And then I can slide this over, and you'll see, sure enough, that's the line we just drew. Shoom, like that. So that's the second way to do that. All right, so that's done. Now we can, from now on, we use these. All right, now how far do we go on this course? Oh, we could label this position. This is a fix, and it's at 0100. Okay, that's a position. Now we go 5.5 miles in direction, 305, 5.5. Now we got to go back over to here. Now 5.5, let's see, my dividers might not reach 5.5. 1, 2, now it doesn't matter, I'm going to use a latitude scale, and this is 1, 2, 3, 4, 5. 5.5, yeah, I can get 5.5. So you see, I start here, and I'm going 1, 2, 3, 4, 5. 5 that's 16. 5.5 is right here. 5.5. Okay, that's how far I go. Now, so I'm coming back here, and I put this here, and I put here, and then there's my position. I mean, there's my point. And I can just reach down and make a dot there. Okay, make a dot. Say okay. So that's and then from there, from that point. Now it's a little cleaner sometimes, you know. Okay, let me just do this again here. If you want a little bit cleaner plotting, okay. So we have that line drawn here. Let me just get that up to here, and there's our line, and then we have our 5.5. From here to here. It's a little bit sharper, rather than like say I said make a dot, right? Or you could just come up here like this and just make a cross. Now that cross is, we're just caring about this point. We're going to probably even erase that. But anyway, there's the point. It's a little cleaner. Now I want to change to a new course, 215, which is going to be 235. So this one's going to 235, true. This one was 325, true. Okay, so now I'm going to 235, true. Okay, so I come back here. Where am I here? And I want to. Now you see, as I rotate this down, then this is going to be in the right quadrant. They thought through that. So I'm going to come up here and just set this, align this one right on the parallel. Then this has to be, see the line goes away, so I can't quite do it. So I have to come down a little bit lower where this parallel line shows. Here it goes away. So I have to go something like this. I line that up there, and I get 235. This is, okay. So this is lined up with this, and that's lined up with that, and I'm ready to go. I roll it up. It's interesting. I'm tacking. It's interesting. I'm tacking through 90 degrees, turns out, right? Because I just drew this like that. All right, so this is, now this is the mark you make for like a DR position. It's a dot and an arc like that. So this you could label, this was course 325 true. And that's one way to label it. This is now course 235. 235. True. Okay, so I've got that and that. Now this I label with a time. This is at position 0200. Okay, that's like that. Now, how far do I go on that one? It looks like I go 6.6 miles. Now, 6.6. This may not be long enough. Now, here's another trick. When I want to extend that line, but I'm not going to try to line it up on the other edge, which is hard for me to see. I'm going to line it up here and then kind of roll it back. And then I just kind of extend it. Now, this scale, by the way, look at that. What's the scale of our chart here? Our chart is 1 to 80,000. 1 to 80,000. Now, that's another trick of this one. This has a scale 1 to 80,000. So let me just see something here. This was what, 5.5 miles? See, look at that on here. See, that's 5.5 right here. 5, see, that's another trick. That's 5.5. 5.5, exactly. So this is our mile scale, same as here. So now life gets easier. We can just go down here to 6.6. Okay, 6.5, 6.6. Looks like that. It's not the end. It's right here at the 0, right? So that's my mark here. Let's see if I'm still tacking through 90 degrees. Okay, so there's now 6.6. And now we turn to course 300.
320, true.
And thank you. 300 magnetic, which is 320. Look at our previous tack, we were on 325. Now we're on 320. That all happens. It's a little, thing, wind shifts a little bit. So now we're on 320. Where's our line? Oh, okay, right there. So here is, I line this up with here, and then this has to be 320. So there's 320. Okay, that's lined up here. That's 320 here. Then I can just roll this up to here and draw the line. Then I'll just make it a little bit longer. Well, I don't know how long I need it, but let me just, right? And all this down here, none of that do I need for anything. I don't need this up here for anything either. Okay, so there we are. However, I do know here I've got a little dot here and a little open circle. This corresponds to time 0312, and that's when we did that. And then this course here was 322. So if we label that course 320 true. Okay, now, how far do we go up it? 2.3 miles. And now we're just using our tool here that we're so comfortable with already. And here is this is my mark, 2.0, 2.1, 2.2, 2.3. And there's the mark right there. Well, in this case, that's our answer, by the way. So I can just do this. So that's like a half circle. It means it's a DR. It's a DR position, and that's for 0337. 0337. So so we don't have, so that was all a little bit, that was slow showing the plotting, but that's now what it would be. That would be your answer if there were no leeway, no wind. Now, what is the wind? The wind is 280 true. Now, remember, 280 is the way the wind comes from, right? So this is 270. There's 280. 280 is right here, like this, 280. Oh, it's interesting. We weren't exactly on 90 degrees anyway. Okay, so there's 280. So I could just come in here anyway and do something like this, right? So here's our wind. That's our wind. So when I'm sailing this way and I have a wind down this way, I'm actually going to go this exact number of miles, 5.5, but I'm not going to go in that direction. I'm going to go over here. I'm going to be down 7 degrees. So what I have to do is just now move this 7 degrees to the right. Let's see if there's an easy way to do that. The easiest way, well, I would just say we add 7 to 3. oh no, it's 325. Yeah, we go this. We get 325 plus 7 equals 332. So this one, the first leg, leg 1 is going to 332 true. So what you would do is come in here now, and now sometimes if you have just a plain protractor, I didn't bring it and you may not have it, so I won't show the use of it, but a big square protractor, let's see, I don't have one here. They're very handy because you just drop it on here and measure the angle. But I can do it this way with 332. So I've got 332, 330, okay, I'm lining this up here, 331, 332, and that's my heading, 332, like this, like that. And then what happens is you go the same distance, right? You go the same distance, so I don't have to measure that again. I can go here and then just swing it over to here, and then here's where my position is going to be now with the leeway, Then I'm going to come down here from this point. That's a point with leeway. I went the same distance, but I'm just downwind 7 degrees. Now I'm going to go the same course downwind. So now it's 235. No, yeah, 235 minus 7 equals 228. So now I want to go 228. Okay, and now I'm starting from here, and this is now my course, like this, right? So this is a corrected course, 332 true, and this is a corrected course here of, what did I say, 228. 228 true. Now, again, I go the same distance, so I can just set from here to here. Well, what was that distance? It was 6.6. So I can just go on here or just take the dividers. You're using the same distance, so you can literally just take it off your plot because we plotted pretty carefully. Okay, there's that distance. It's the same distance, but now I'm just offset to here. And then here's now my position. This is my corrected position at 312. And then now my course, again, the wind is this way, so I'm getting pushed this way. So it's 337 minus 7. Oh, I should have worked that one out in my head, 330. So now I want 330. 330. Okay, 330. Where's my point? Here. Okay, so here's 330. And then that's a course up this way. And again, we go the same distance. So I just go from here, go here to here. And then here's my answer. So there's my answer with a leeway. Now, did they give the answer here, solution? Well, I'm not going to tell you the solution. I'm just going to check it. Let's see, there's my answer right there. And if you read it off this video, you do that at your own peril. I'm going to just see if it's anywhere near right. Bang on. Maybe I better not check the longitude. Okay, the longitude. Okay, so how did I check the answer, right? Here's the answer. I went from here to here, right, to the nearest parallel of latitude. I went from here to here. That's the answer. Then I come over here, and sure enough, I read 21.2, just like I'm reading it off the answer sheet. Now, the longitude, I would just go over here and measure from here to here. That's a distance. I'm to this side of that meridian, and that comes up here, and that reads 15, 16, 17, 18. I get 19.3. Ah, they have 19.7. Okay, well, one of them is right. You can check it out. That's not that much difference. But anyway, it could, yeah, I don't know. Anyway, I get close. You would, if you put that answer, you'd probably get the right answer. But anyway, that's how it works. Let me just see if I did that right. Yeah, I get 19.3. Anyway, I'm not sure what's right. Anyway, that's the process. So you have now two solutions of this. One with the traditional plotting with paper and these tools, and the other is online using the OpenCPN and various electronic tools. It'll be interesting to see how those two compare. Okay, that's it. Thank you.